everyone, and welcome. If you're feeling the pressure of rising material costs, tight labor markets, or unpredictable supply chains, as we all are, you are certainly not alone. Fabricators and stampers everywhere, we all know the pain. They're all being forced to rethink their approach to blanking. And in this session, we're taking a little clear-eyed look at the cut-to-length or CTL processing. I spent quite a few years in that end of the business, and I could tell you it's more challenging today than it's ever been. So you definitely need to look at alternative solutions if you haven't done so. So we'll break down when a CTL line becomes more cost effective than buying blanks and what that decision really hinges on, like, of course, scrap rates, scheduling flexibility, facility readiness. We'll also help you make some sense of the key ROI drivers, because we all need to keep an eye on those, from material utilization and labor efficiency to, of course, quality control equipment integration. Our guests today are experts in this area and will walk us all through what it takes to make CTL work, from choosing the right coil supplier to avoiding the most common missteps during integration. Those guests, of course, Reed Coe, who I've had the pleasure of meeting many a time on my podcast and then other areas. So welcome, Reed, who is, of course, he is the president of Coe Press Equipment, where he leads strategic operations and drives innovation in coil processing solutions for our metal stamping and fabrication industries. With a background in business and communications, he brings deep industry insight and customer-focused leadership. Also with us today, ding, 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 John Kwiatkowski. Is that, did I butcher that too bad?
Yeah, it's John K. The next 10 letters are silent.
I grew up in Buffalo. So what area did you grow up?
Metro Detroit.
Okay. Same area, just a different side of,
exactly.
of another lake, you know. It's John, of course, is the sales manager at Coe Press Equipment, and he brings hands-on manufacturing experience and deep technical knowledge to the conversation, with a background spanning tool and die, engineering, service roles. He's uniquely equipped to guide manufacturers through the CTL integration and optimization. Hi, guys. Welcome.
Hi. Yeah, thanks for having us.
Thanks for having us, man. It's so good to see you. It's awesome to be a part of this.
It's phenomenal to have you guys back on here and get a chance to see you, especially with FabTech right in our midst. So great to see you guys. When does a CTL line become more cost effective than buying blanks?
I would say when you start to look at a process where you have many sheets coming in that require multi-pallet solutions, right? So you're essentially, what can happen very quickly is if you're processing many different blank thicknesses. So this is on the low end of the volume, but if you have many blank thicknesses, they'll come in separate pallets. And it can take up quite a bit of floor space. So that's one reason to start thinking about it. You know, there are compact solutions that don't take up more than 40 by 20 foot space, which is pretty minuscule when you think about how many blank stacks people could have around their plant. Or when you hit certain volumes, when it's simply just going to make you money because of the volume you have. And the other one you mentioned earlier was scrap. There are certain scrap with different standard lengths that the industry wants you to buy, and they charge you less to have them cut you that particular length with whatever their nesting solution is going to be on their laser, whatever they're utilizing. You lose a lot of the metal that you're buying, right? So that's then the other solution. So I would say a combination of those three would be the reason.
Absolutely. Plus process control, right? It puts you in charge of it.
Right. I totally agree with that. Yeah, the process, like what John's commenting on, if somebody wants to cut certain blanks in certain sequences, or the quality control of the product, right?
Yeah.
Yeah.
Or even if you have a little accident with a couple of parts and you need 1 or 2 sheets on demand, when you have the equipment in house, you can just whip those out. You're not waiting for a truck to come and bring you another stack of them.
Yeah, that's such a good point.
That's a very important aspect, because when you need ones or twos, you want to be able to control that, because if you don't, man, that's, especially for companies that are dealing with automotive and stuff like that, that could be a horrendous and catastrophic end result. So,
Yeah.
how does coil-fed blanking help reduce scrap material?
It's mostly it comes from the reality of being able to cut whatever length you want and ordering whatever width coil you want. There are some solutions that are out there that slit and cut. The only thing that we, at least at COE, focus on in our application is that the slitting process is very fast, right? So when you're putting it into your cut to length process, you're essentially taking more time and you have more complication in navigating the blanks after they've been cut, because typically they go to different pallets and they don't get pulled off of the same pallet typically. And even so, you're reaching over other blanks to get to blanks. So what we recommend is that you find a supplier who can slit a coil to a certain width, and then you can cut it to blank, to the blank length that you want. And that gives you huge reductions in scrap length that you would be having if you had somebody else cut you that standard length that we were talking about earlier.
And so what factors are most important when you're choosing coil suppliers?
I would say when you're looking at a supplier, you want somebody who's going to be delivering quality. I think a lot of times in this world, we get caught into this process of a purchasing agent being incentivized to buy the cheapest thing or the lowest cost that they could find, and they don't necessarily see it as cheap, and maybe that's just a triggering word. But the problem is that they're not necessarily buying for consistency, and consistency, as we all know, is much more profitable than low cost when it comes at a cost, when low cost comes at a cost. And I think that that's really the number one reason to.
Yeah, but buying anything, subpar on a coil, you're tripping over $1 to pick up a dime. It just doesn't make sense.
Right. Yeah, and I think too, like the thing, we see this a lot, right? There are people who they get caught kind of in their own trap by saying, oh, well, this supplier couldn't give me this coil at this quality, so I need this piece of equipment, which is an extra $1 million, right? When they could be shopping, they could be asking maybe the manufacturer of their equipment who they would recommend to go buy coils from or to source from. These purchasing relationships get so strong that people don't want to branch out. And we find that that being one of the most restrictive things that make them kind of back themselves into their own solution when maybe they didn't have to.
It's a challenge out there, especially with materials. I think most people don't realize how challenging that can be, but
yeah,
I think you guys know.
Yeah. Yeah.
So what kind of facility preparations are essential for CTL integration?
Do you want to take this one, John?
I mean, probably the big obvious things, right? You want to make sure you have enough floor space for it.
Yep.
I think Reed commented earlier, a lot of times you're utilizing a ton of space just stacking up pallets of blanks, and that space can be repurposed. Obviously, a coil of steel takes up much less space in your facility than the blanks that coil could create. Kind of gives you also the advantage of being able to do a just in time, right? If you need a day's worth or a week's worth of blanks, you can make those on demand as you need them, of course.
Right.
So floor space, which again, there's a bit of a trade-off there with your coil storage or your blank storage, and concrete, utilities. I mean, kind of the basic factory stuff we're all used to doing.
Yeah, I agree. I think just to put it into perspective, a coil that's 42 wide and 72 tall, there's standard 72 OD is what they come in, right? That's a 45,000 pound coil. So that takes up, normally people do 6,000 pound stacks. That's about a maximum of what your laser system can handle. So you can imagine how many stacks on the floor versus just taking up 42 inches by 72 tall, right? How much more compact that is.
And that's without getting into racks or anything else.
Right.
That's a good caveat to when people get into that. So I'm glad you brought that up. How well do CTL lines manage variations in, say, coil width, gauge, and yield strength?
That's probably where they do the best. That's probably their biggest strength, is in those particular variables. The machine itself, depending on who has spec'd it and what materials they've asked for it to process, it's usually within, let's call it, how we would spec it at COE would be, 80% of the capacity of the machine's ability to run even materials more than what they are asking for. So typically, it's in a sweet spot to just kind of simplify the answer. And I think, what a lot of people don't understand is that these machines were made, especially on the cut-to-length line side, these machines were made for 24/7 facilities. So 3 shifts a day, right? And the amount that they can process for a typical fabrication customer puts them in the driver's seat, because they actually can get most of their workload done. For example, we had a customer that made mower decks, and they made thousands of mowers a month. They were processing, I think they had some version of 7 or 8 lasers, trump lasers.
I believe so.
And they could keep those 7 or 8 trump lasers busy, only running production 5 hours a day, 4 hours a day, 5 days a week, 3 days a week, depending on what their workloads were. So now this becomes a revenue generation tool as well. So you can go and cut blanks for other people now. So that's where it really is. It's such a comfortable place when you're looking at variations of range materials. It's just a very cut and dry answer. It's, can it do this? Yes or no. And so for a customer who has one of these, the confidence level is very high.
Yeah, and when you get into different material, types, widths, thicknesses, the width is an easy part, right? I mean, there's adjustable guides on just about any machine.
Yep.
You can handle from, maybe something down as thin as, 2 inches all the way up to, 60 inches, 72, 78. So width is a real easy variable. When you get into material type and thickness, yield strength, that's generally determined by the type of straightener that you select. And that's done, up front when we're speccing out the equipment. Any straightening machine is going to have we'll call it a sliding range material that it can process. And that's going to be based on the roller diameter and the center distances, right? So when you get into heavy gauge materials, you're going to have a much larger diameter roll, typically with a wider center distance, to be able to chew up that 1/4 inch, that 3/8, that real thick, heavy material. As you get into those large rollers, you start to drop off a little bit of the material on the bottom end. So that giant machine that can deal with the heavy stuff, you might have a lower limit of maybe 040, 060 mild steel or something like that. When you get into the smaller machines, and I don't say smaller in a bad way, just a different scale, that whole material range slides down. So now maybe you can get into the 010, 015, 020 stuff, but maybe your max becomes 100th hour, 1/8 inch.
Right.
So it's real important to kind of know what work you're doing on the front side, and work with your supplier to get that spec'd out.
Yeah. Yes, it is. Yeah, really, I would say this, that the thing that people really need to pay attention to when it comes to these things is their coil defects. That is really the subject matter, where their purchasing person, if whoever's watching this, if I could shake the camera, make sure your purchasing person knows what a coil defect looks like and what an acceptable coil is. That really is going to be the crux of being successful.
Yeah, agreed.
Yep.
What's the typical timeline from CTL order to production?
It depends on the size and complexity of the machine. So we've had some CTL lines that are quite small come through, and for us, from order to delivery, around 15 weeks.
Yeah, I think even 12 on some real little guys.
12, yeah. And then we've had some, John sold one last year that it was some version of a 30-week lead time, 20-something week lead time.
Yeah, but that was a high automation system, big heavy gauge line.
Right.
A lot of moving parts in those.
Right. These coils you see behind us are going to a cut-to-length line. And that one was It actually has a press in the middle of it. It has a push-pull feed. It has a double-ended 30,000-pound reel. And that one was somewhere in the 30-week time as well.
Okay.
Stacker.
That's still pretty good. That's still pretty good nowadays, you know?
Yeah.
What training is required for operators of a CTL line?
So I would say this, when we sell installation, and I think it's really critical, even for those that are used to the process, even on a stamping side, there's always going to be a natural evolution of process. Even with the same machine, same controls, a service person could come in and say, I've actually found if you do this sequence, this, as opposed to, like, let's say with loading a coil, I found if you rotate your mandrel and this pad is here and you do this, and this first, versus just putting it on and tightening the coil there and then trying to tweak it later is a better process, right? There are these little tweaks.
Yeah, best practices.
Best practices that evolve. Best practices that evolve. It's a much better word. Yeah.
And as far as the learning curve, I mean, a lot's going to depend on the machine, right? And the customer, of course. So if you have a shop that's looking at a CTL line that already has stamping presses, what we call the back end line, right? Everything behind the shear or everything behind the stamping press, it's all basically the same equipment, right? You're uncoiling it, you're straightening it, you're putting it into a storage loop, and then it goes into a servo feed, and that's what's going to meter out the correct amount of material that you need for either the part you're stamping or for making a sheet. So that's all the same. So in a facility where they're already accustomed to stamping, I think that learning curve is going to be way shorter, right? What we see is a lot of times these are going into OEMs where it's a huge process change, right? They've been buying sheets for the last, 10, 20, 30 years, however long they've been in business. And, you're kind of upending the cart when you bring in these cuts of length lines.
Right.
So there's a bigger learning curve there. Not to say that it's something that people can't overcome, but just, it's going to take a little bit more training, a little bit more practice to figure out your best practices.
Right.
The other element of this is going to be, of course, automation, right? If you make the investment up front into automation, that cuts that learning curve way down. If you have operator turnover, you're not retraining people to the same level that you'd have to. The machines get intelligent, right? You push a button, you call up a job recipe, and things just automatically move into the position they need to make the parts that you want.
Right.
You get more advanced. We even have onboard calculators and utilities that'll automatically set things like work rolls for you, and save that all into job recipe.
Right.
So high automation, you're going to spend a little bit more money up front, of course, but then it's going to pay off for the next 10, 20, 30 years.
Right. Yeah, it really does come down to the complexity of the line, and whether you've had that process in your plant, and then that would obviously change the duration of your training. But the biggest thing I think people need to understand to kind of demystify this is that it is a very simple process. So once you get the ability to have an operator understand the overview of what you're trying to accomplish, it's a very simple line to become familiar with. It's much more simple. I've been dabbling with a lot of 3D printing, right? And there are these engineering grade materials where you have to have like a mad scientist lab knowing the relative humidity with the temperature, measuring dew point alarms and all sorts of stuff to make sure that it prints the one profile that you just set. These machines aren't like that. These machines are, you find the roller settings, you make sure that your loop settings are right, and you feed whatever length you've put into your servo control, right? Your HMI for your servo feed, and it does the job.
Yeah. You define all that stuff once when you're doing the job setup. It goes in a recipe, and then it's just an operator recalling the job.
Right.
Job number A1. That shows up on the screen. They hit the go button. They call it a batch. They say, hey, I want 10 of these sheets, 20 of these sheets, whatever that might be.
Yep.
And you hit the start button, and the thing runs. When it's done, it spits out a pallet of parts for you.
Yep. Yeah, I'd say let's call it 70% of training is safety related.
Yeah, for sure.
Not necessarily operational complexity.
Mm-hmm. And so now, what common mistakes, as an extension of that, what common mistakes should manufacturers avoid during CTL integration?
It's a good question.
Well, I think one of the biggest ones, of course, is materials, right? We've talked about that already. I mean, obviously that's kind of a bugaboo. You have to get quality coils in on the front side.
Yeah.
And if you're dealing with any camber or crossbow, I mean, camber is induced by a dull slitting knife typically.
Right.
Any kind of junky coils you're going to fight with, and you're going to fight with from start to finish.
Yep. Yeah, I think that's right. I think the first thing you establish is coil quality standards. Sorry, John, I interrupted you. But I totally agree. I think that's the first thing to do. The next thing to do is figuring out capacities in the building. So we have a lot of customers that either want to make this some sort of a big swing where their building has cranes added to it and they either build a facility out, or there are customers that want to figure out how to fit it in there and load it with a coil car, load their coil car with a high-low, right, or a fork truck. So, those things really come down to engaging with your supplier of the machine, figuring out what your process is going to look like, because the different width of coil will really change a lot. And then also whether it's pre-painted, if there's cosmetic materials, those things will change the process as well. And I think that facility-wise, and I think that's more so, is that more so your question is the facilities, like what's going to change in their world? Or
yeah. I mean, what kinds of things do they have to see the pitfalls coming from? So if I'm going to do this, what kind of things do I need to kind of be prepared for when I'm doing that?
I think most of it's preparation, right?
Yep.
They want to take into consideration their workflows in the facility, right?
Right.
So generally, you're going to have a truck dock in your facility where you're going to bring the coils in. You need to make sure you have the right crane capacity or the lift truck capacity to deal with that. And then how is this stuff going to flow through your plant? So we know we have a truck coming in with coils on it. We have to unload the coils, get them into maybe a staging area. And then you want that to probably be near the cut to length line, of course, for convenience. And then where's the output of that line? What's the next process? In a perfect world, it would all flow in stream. So
Right.
you'd have a truck dock, coil storage right behind the cut to length line, perfect world, right?
Right.
We load the coil, and then on the other end, we're getting out sheets, and then that could go right into the laser that's next door to it, for example. That would be perfect.
Right.
Now, we don't live in a perfect world, so most
Right.
facilities are not set up in this exactly utopian arrangement that I
Right.
just described. But with a little bit of planning, you can figure out what your best workflow is going to be.
Yep.
And but think about that stuff on the front side, I guess, would be my big message.
Yeah, it is all in the planning. I totally agree. And the machine will change what your process, what you're trying to make will change the machine, will change your process. Best way to put it. So it really does come down to when you're engaging with your supplier, making sure you heed their advice on best practices in the plant.
And that kind of gets back into automation too, right?
Right.
If we can establish a good workflow, I mean, we've quoted systems that would pay right into a tray for a tower system, right? So then you're kind of taking the operator out of it almost completely.
Yep.
The tower would call for a batch of blanks. A cart or an AGV brings the empty tray over to us. We fill up the tray, and then it takes it away, puts it back into the tower.
Yep.
And then on the other side of that, the laser's calling for that material, and it's delivering the tray material to the laser.
Right.
Of course, bigger investments, right? It's always going to be at a price, but
it is.
It's that planning and thinking about what the big picture looks like for you.
Right. But what's I think what's nice is there's kind of this fear of changing because people are used to just getting blanks, right? So they feel like this is some sort of it feels very like dark, right? It feels like a dark room they don't want to walk into. And so I think the thing too to communicate to people thinking about this is that it's only going to give you the ability to run just in time. It's a process that's not going to consume a person for all 8 hours of the day, the whole week. So now you have versatility where somebody is a line operator, but they're also they can also sweep the floors. I have no idea. Maybe they're going to go run the laser. I have no idea what they would utilize this person for. But the things to really care about is like what John's talking about is the coil defect and finding somebody, because typically what we see is when you go from this relationship where this supplier of blanks is putting food on their table with the blanks they're selling you, but they also sell coils. Going to this same vendor they're not going to want necessarily you to switch to coils because coils have less markup in them, right?
Yeah, they make their money on the processing, right?
Exactly.
I mean, typically, anytime you drop a blank, you're paying a per cut. You know, I mean, whatever
Right.
that number is. If it's 50 cents every time they drop the shear, or $1 every time they drop the shear, I mean, that adds up into their bottom line.
Right. So again, like John mentioned in the beginning, the biggest pitfall really is getting quality coils, but first even thinking who you're going to get coils from, because typically, and it's just a typical thing, and I'm not trying to, be disparaging, but typically your supplier of blanks, if they also do coils, making sure you get a second quote. And you figure out.
Yeah, a little bit of conflict of interest there, right?
Right.
Yeah.
Yeah, making sure you get a second quota of a coil supplier, and then your ROI, all the development of your ROI. We have an ROI calculator so that a customer can come to us, and then we can put in what their blank utilization is, what their weight per stack is, and then we can get help them on the other side get quotes for coils, and then see what their coil weight price is, and then we can figure out what their scrap utilization is and all these things. And really, that's kind of the more complex part of the process than it showing up in their plant. Because when it shows up in their plant, we come in, we do the training, they start running coils, we make sure that they have the right quality system, and it's usually with very few exceptions, something that they just kind of walk away from, and Billy runs the line 4 hours a day.
Okay.
So I think that'd be the best way to put it.
Yeah, the other big thing too in the ROI is the trucking fees.
Right.
I mean, you see these trucks going down the road. I always cringe when I'm next to one, but I mean, they'll have 8, 10 coils on the back of it. Think about how many stacks of sheets that would be if those were already processed.
Right.
You might need 4 dedicated loads to bring in the sheets. And you're just paying for one when you're bringing in a handful of coils.
Right.
I mean, the trucking fees are huge by themselves.
Oh yeah, for sure.
Yeah. And you kind of touched on this, but what process changes are required when shifting from outsourced blanks to in-house CTL?
Your storage area changes because now you're cutting just in time. You're able to cut when you need it. So you don't need to have them ship in 4 or 5 trucks anymore, because you're going to have a month's worth of production. You have 1 truck show up. You have 1 unload occur, right? So you can imagine the duplication of efforts that occur when you're running blanks versus a coil. So I would say that's probably the biggest process change.
Mm-hmm.
And then I guess getting used to the line being where it is physically, and having your high-low routes go to the end of a line as opposed to wherever you're storing your blanks.
Yeah, just really getting in that workflow thing again.
Right.
Yeah.
Yep.
Right. Yeah,
Pretty
that's
simple.
a good point. Yeah. How does moving in-house CTL affect the manufacturer's ability from a quality standpoint to meet quality standards?
I mean, it puts you in the driver's seat, right? I mean, if you're making sure you're specing out good quality coils and your supplier's delivering to you, I mean, you're in control of that quality.
Right.
And plus you're reducing handling, right? If you think about having a processor do this, now you're going to stack these blanks onto a pallet, and they're getting handled a lot more. They're getting loaded on the back of a semi-truck. They're getting unloaded.
Yep.
You're shuffling them around your plant.
Yep.
Every time you touch that, that's another opportunity for a bent corner or dinging a whole stack. I mean, you can lose a whole stack just by a forklift bumping into it.
And then you can't replace it until somebody trucks it to you.
Exactly. Yeah. You're tied up until they send you another truck.
Yeah.
And so when you're doing it, you're in the driver's seat. You're reducing those touches every single time.
Yep.
And of course, if you have an issue, the forklift guy does back into the stack. You can make another stack. You're not waiting for a truck to show up to get you back online.
I think the other thing too that a lot of people don't think about is that you can have a quality defect, call it 15 sheets below your top sheet, and you have no idea that it's there. And so by the time you're consuming through these blanks that you have, you can run into a defect and lose production you couldn't even predict. With a CTL, you can watch the blank stack. You have the whole process occur from the coil and you have all that distance of people watching this thing run all the way to the stack, observing quality of the coil, and be able to predict when you're going to get a bad blank, even if it wasn't the coil. It's very easy to anticipate.
Yeah, finger on the pulse, right? You don't have
Exactly.
that opportunity when an outside processor is doing it.
Right.
But when you're doing it in-house, if you're in the middle of a stack and an operator walks by and says, oh, wow, that doesn't look right. You have the ability to stop, maybe change your setup,
Right.
or
Scrap
identify
it.
that you have a bad coil and say, hey, this thing's, a mess. We got to send
Right.
this back.
Right.
You're not waiting until it's, on your floor and queued up for production to catch it.
Exactly. Yeah, because it's usually an interruption. The thing is it's you're avoiding an interruption. You can always cut that bad blank, but if the operator of the laser doesn't know that there's a bad blank in there, he's got to stop in a place that he's not really meant to be scrapping one blank, right? He's got to figure out what he's got to do with this thing. He's got to put it someplace. The machine's not running.
Yeah.
Right.
These are always a manual process.
Exactly.
Right? You get out a sheet handler or something to do it. It's
right. Or you could catch it on the front side because you can run your CTL so much faster and you can run all your lasers that you don't even feel it.
Good point.
Yeah.
And again, going back to automation, you can get into vision systems and things that will detect that for you. They're just
Right.
monitoring it, and you've defined parameters of what you consider a good part, right? Because that's a little bit different depending on what the downstream process is.
Right.
And it will say, hey, there's a problem, and stop the line for you.
Right. That's right.
Good point. Well, guys, that does it. Thanks to you both. Reed, John, thank you so much. You shared a ton of expertise about CTL with our viewers today. We really appreciate it.
Thank you for having us.
Yeah, thanks again. Thanks for having us.
Absolutely. And now here's more from Cole Press Equipment.
Your business operations require reliable equipment to run today's metals, including advanced, high-strength steels. So if you settle for anything less than the best solution, everything suffers. At Press Equipment, we build, without question, the most reliable, robust solutions for coil processing applications. From coil reels to straighteners, servo feeds, shears, stackers, and everything in between, we produce quality solutions to uncoil, straighten, and feed your production environment. And our first-class service team ensures your equipment, be it Co. or other brands, is always up and running. Whether you need a machine upgrade, a conventional feed line, cut-to-length line, progressive line, or something specific to support fine blanking or roll forming, we have the right solution. The Co way of thinking impacts what we deliver, and that makes us unique. Our goal is to offer more than just great machines. Instead, focusing on providing the best combination of innovation, quality, product, price, delivery, and service for our customers. You shouldn't settle for pretty good. We know there's always a better way, which is why when it comes to helping customers, we apply the science behind the solution to continually improve. And when science speaks, Co listens. Engineering and research drives our product development, ensuring our solutions deliver the performance needed to empower manufacturing. We also recognize that listening to our customers and understanding their needs is key to leveraging our expertise, helping them consistently optimize and maintain high production environments. How we do business cultivates long-term relationships. We value our customers' trust and put everything on the line to earn it. At Co, we're about more than just building great equipment. We also help our customers build great businesses. Contact us to learn how we can do that for you.